Hello dear friends, welcome to the fascinating world of physics. Today we will start with the idea of kinematics. Kinematics, as you all know, deals with the motion of particles without bothering about the cause of motion. Cause of motion we will study in connection with Newton's laws later. And in this lecture, this is a basic lecture which we will introduce the fundamental quantities required for analyzing the motion of a particle. Our basic aim is to develop the ideas of distance travelled, displacement, average speed, average velocity, etc. Later we will study the instantaneous speed, instantaneous velocity, etc. And before that we will develop the mathematical tools required for analyzing the situation. In all the lectures which we are handling, we will provide the necessary mathematical tools required for analyzing physics problems. And you are watching the channel Physics Ladder, which aims at helping you to ascend your academic ladder by strengthening your problem solving capacity and also the conceptual understanding. I am K.P.Satheesh. We will start with the lesson. Kinematics is the study of particles, motion of particles. Therefore, the first idea we have to discuss is the position of the particle, because we know that motion, precisely motion, means the change in position. Change in position of the particle is called motion. So, if you observe a particle at a particular instant of time, we estimate the position of the particle. Then we observe the same particle at another instant of time. We measure the position of the particle. If you see these two are different, we say that the particle is moving. Otherwise, the particle is at rest. So, we require a procedure for fixing the position of a particle. Procedure for fixing the position. And the position which we fixed should give the point uniquely. It should not be shared by some other point. Therefore, the description should be unique. Therefore, the unique way to express or represent the position of a particle, the position of a particle uniquely is a coordinate system. So the position of the particle is described by a coordinate system. A coordinate system is the specification of real numbers to represent the position of the particle. In 3 dimensions, we require 3 numbers. In 2 dimensions, we require 2 numbers, and in 1 dimension, we require 1 number. These numbers are real numbers. So we have a real number line, and numbers are required. So we have 3 real numbers. So we have three real numbers required to represent the position of a particle. These numbers we can take in any way, therefore, but here in most of the elementary level analysis, we take it as the rectangular Cartesian coordinate system. So we have the rectangular means the axes are mutually perpendicular. Cartesian is the name of René Descartes, who has discovered coordinate geometry, and it is a coordinate system. So we describe the rectangular Cartesian coordinate system. This is used to represent the position of a particle. Rectangular Cartesian coordinate system means we have three lines, one line like this, another line like this, and a third line like this. These lines are called coordinate axes. Coordinate axis. Conventionally, in representing three coordinate systems, we take this as y, this as x, and this as c or z. And we represent a point here by giving three numbers which are represented as x, y, and c. This is usually called an ordered triplet. This is an ordered triplet. Triplet because we have three numbers, and triplet, x should be taken as the first number, y should be taken as the second number, and c should be taken as the third number. We cannot change that order. If the order is changed, we will reach another point. So, in order to fix the point, we have to use three numbers which forms an ordered triplet. This x represents, y represents along the y direction, and c represents along the c direction. And these axii are graduated 1, 2, 3, 4, 5 like that. It is graduated. We can use a meter stick or a graduated ruler, etc. to of the axis. They can be considered as rigid rods in three mutually perpendicular directions. When I draw in the board, I draw it like this. Actually, we can take it. This is one direction. This is another direction, and this is the third direction. I have the c-axis like this, y-axis like this, and x-axis towards u. If it is two dimension, we take only two axii. One will be called x and one will be called y. If it is one dimension, we have only one axis, that will be called x. We are representing this in three dimensions. That is the most general case. In advanced level, you have to include higher coordinates also, but here we are having maximum three coordinates. So these three coordinates, which are the ordered triplet, and we will see how to represent that. That is the first task we have to do to fix the position of a particle. So suppose I have x, y, c as 2, 3, 4. That means I have to mark off 2 units along the x-axis. That is, I have to go along the x-axis 1 unit, 2 unit. I have to reach here. Then I have to go along the y-axis for 3 units. I draw a dashed line parallel to the y-axis like this. This point is 1, 2, 3. From that point, I draw another dashed line parallel to the x coordinate. These two will be intersecting at a point. This point is actually the point 2, 3 in the xy plane. If we have 2, 3 forms the xy plane, and to mark this 4, we have to go along the y direction, c direction. So I draw a dashed line in that direction. Then I have, this is the 4. I go along the x-axis parallel to that, like this. From this point 2, I mark a line like this. These two will be intersecting at the point 2, 4, which is the coordinate in the xc plane. Then I draw a line from here like this. This point represents 2, 3, 4. This point is the projection of 2, 3, 4 on the xy plane. This is the projection of 2, 3, 4 on the xy plane. This is the projection of 2, 3, 4 on the xz plane. Similarly, I can have a projection on the yz plane also. At higher levels, you will have to take the projection of points. That is why I am specifying what you mean by the projection of a point. This is how the coordinate system is position of a particle. You must note that this 2, 3, 4 is not shared by any other particles. But we can take points along the y-axis towards the left and mark it as negative. This is positive. You can take x-axis in this direction, we can take it as negative and this as positive. We can take c-axis like this. This is negative and this is positive. So in coordinate systems, the lines towards the right or up or towards you are taken as positive. That is the convention I will be using. To the left, down or away from you is taken as negative. So if we say this as 2 minus 3, 4, that means this 3 is towards the left y-axis. In the case of two-dimensional coordinate system, if we require, in most of the cases in our lesson, our area, we will have to consider only 2 dimension and 1 dimension. 3 dimension comes occasionally in questions, but we don't usually need to plot that. Usually we will plot the 2 dimension case. In the case 2D, you have a horizontal axis which we call as x and the vertical axis we call as y. Then if we mark this point as 5, 7, it means that this is 5 units along the x-axis and 7 units along the y-axis. They intersect at this point. All the values towards the left is taken as negative, down is taken as negative. In 1 dimension, we require only 1 number, that is a line like this. There is a point and this is x alone. All the values to the left of this point is taken as negative and the right of the point is taken as positive. This is the representation. And all these vertical lines and horizontal lines, there are three mutually perpendicular lines like this. They meet at a point. They are concurrent lines. They meet at a point, but they are not collinear. They are not lying along the same line. They are mutually perpendicular. And the point at which all these axii coincide, that is called the origin of the coordinate system. So by specifying the origin and also by specifying the coordinates, we can fix the position of the particle uniquely. That is the way in which the position of the particle is uniquely represented. But this is not complete, because we know that in the analysis of kinematics we require motion. That is, the particle changes its position, which can be determined by the specifying the coordinates of the particle, but time also is to be involved. So we define a time coordinate system. Time coordinate. Time coordinate means it is a clock, and you mark the time along a line and another number line like this. Say 1 second, 2 second, 3 second, like that, or 1 minute, 2 minute, 3 minute, etc., or 1 hour, 2 hour, etc., or 1 day, 2 day, etc. You can choose your convenient unit. Usually we take distances in terms of meter and time in terms of second. That is the convention we will be employing. We are using SI units. So this is the time coordinate system. And for the time coordinate system also, we have to fix an origin. Therefore, this is taken as 0, which is the origin of the time. We know that time flows continuously, and so fixing the origin of time coordinates means we are choosing a particular time as the starting point. In some cases, we take the starting point or the origin of the time as the point at which we start the observation. In some other cases, usually when initial conditions are given, initial velocity, initial speed, initial position, etc. are given, we take the initial time as 0. That depends upon the problem. Either it will be the initial time or it will be the starting of the observation. You can fix the time. For example, imagine this is 10:35 and I mark this in minutes, 2, 3, 4, etc. minutes. Then this is 10:36. 10:36 is taken as 1. 10:37 is taken as 2. Like that. And all the times before the origin, say 10:34, this is taken as -1. 10:33 is taken as -2. So time can be positive or negative. All the times after the origin is taken as positive. All the time before the origin is taken as negative. Don't think that time cannot be negative. But in most of the situations which we handle, we require a time interval. That is the time difference between two times. They are called the time interval. Time interval is always positive. It is denoted by a number and a unit. If we say that time interval is 10 seconds, it will not be minus 10 seconds. It will always be 10 seconds. It is a scalar quantity. Scalar quantity in the sense that we can specify it by giving a number and an unit. No direction is required for specifying time interval. Therefore, it is always positive. It is always taken as positive. Now if we have the time coordinate system like this, and we have a space coordinate system which we have described earlier, therefore we have a coordinate system, a coordinate plus time. This is a ruler, 3 rulers mutually perpendicular. This is a clock. These combined together we call as a reference frame. This is called a reference frame. All measurements we are making in kinematics will have a reference frame in its backdrop, and the position of a particle at a particular instant of time represents a point in the reference frame. When you are measuring the position of a car standing on the road, you mark the positions at different times. For another person who is sitting on the car, he is at rest. For a person outside, he is moving. So, the position of the particle and motion in general depends on the chosen frame of reference. So, we take for granted there is a reference frame in the backdrop. Usually, it is a reference time fixed to the ground. Sometimes, we need a coordinate system which is fixed to the moving object. That also will be needed sometimes, and that is called a reference frame. So, a reference frame completely describes the position of the particle, as well as we have fixed the position of the particle. Next thing we have to do is to understand how it is moving. For that, we consider a particle which is having a coordinate like this. This is the x-axis, this is the y-axis, and imagine that the particle starts from the origin. This is A. Particle starts from the origin, and this particle moves from point A to point B. Let this distance be 5 meters. And then that particle moves from B to C along the y-axis and reaches this point, which is at a distance 3 meters from B along the y direction. That is, it has reached the point 5, 3. From that, it is moving towards the left by 2 meters. And this point will be 5 minus 2, that is 3, 3. So this is the path of the particle, which we call as the trajectory of the particle. And the total distance covered by the particle by the particle this point we call as C, this point as D. From A, B, C, D. This is the total distance covered by the particle, and this is called the path of the particle. So the total distance covered by the particle is called the path length. Path length of the particle. It is a number. It has travelled a particular distance from A to D. This point A is called the initial point. Initial point. This point is called the final point. The distance the particle has actually travelled between the initial point and final point is called path length or distance travelled. It is a number. Since it is a number, it do not have a sign. It is simply a number, and we call it as a scalar quantity. It is a scalar. It do not have a plus sign or minus sign. It do not have a particular direction, etc. It is simply a number. Here, this 5 meter plus 3 meter, that is 8 meter plus 2 meter. That is 5 like this. This point is the origin. This is the x-axis. This is the y-axis. A particle starts from the origin A and it travels a distance, say 5 meter, and reaches here. From there, that point is B. From B, the particle travels to point C, which is at a distance 3 meter, and then it travels back to the point D. This distance is 2 meter. So the total path, the path of the particle, that is starting from A through B through C through D, that path of the particle will be having a length which is called the path length of the particle or the distance travelled by the particle, and that is equal to 5 plus 3 plus 2 equal to 10 meter. So we understand that the path length of the particle is 10 meter. Now, from this point A, which is the initial point, to this point D, which is the final point. So this is the initial point and this is the final point. You consider a vector like this. Vector we will see in detail later, but that is represented by a directed line segment or an arrow. The head of the arrow represents the direction, tail of the arrow the starting point, and this length is the magnitude. So this is a vector. That vector is called the displacement vector. So displacement is a vector. Displacement vector. Distance travelled is a scalar, but displacement is a vector. So this distance we can easily calculate. This is equal to 3. This is equal to 3. Therefore this is root of 3 square plus 3 square. And this angle theta, which gives the direction of the vector, that is tan theta equal to 3 divided by 3, that is equal to 1. Therefore, theta is equal to 45 degree. So, the distance travelled is 10 meter, that is a number, but the displacement is a vector having magnitude 3 root 2 meter inclined at 45 degree to the x-axis. That is how the displacement vector is to be evaluated. Particle. We can see that the distance between 2 points can have different values, but the displacement between 2 points will have only one value. For example, you consider a point A and another point B. We know that for reaching point B from A, we have infinite number of paths possible. I can go from A to B like this. I can go from A to B like this. I can go from A to B like this. This is path 1. This is path 2. This is path 3. We can calculate the path length. This distance plus this distance plus this distance plus this distance, like that. You, for example, you take a string and place it along this curve and straighten that string and measure the distance. That will be the distance covered. Similarly, you can measure this distance. Similarly, you can measure this distance. It is obvious that those distances will not be same. Those distances will be different. So, the path lengths between 2 points will not be or need not be equal. They will be different. But the displacement of this particle is from the initial position A to the final position B. It is a vector that will be represented like this. Has a fixed length. Say this is 5 meter, this is 20 meter, this is 15 meter. Path length for path 1 is 20 meter, path length for path 2 is 5 meter, path 3 is 15 meter. But the displacement is always a vector from the initial point to the final point, directed from the initial position to the final position, and having a magnitude 5 meter. So it is a vector having magnitude 5 meter. This is the path length. Path length can be different, but this is. So we can see that this is the shortest distance. Shortest distance between initial point and final point is the magnitude of the displacement. It can be same as that of the distance, like this AB. It can be different from that of the distance, that is like this. This is the idea of displacement of a particle. It is the shortest distance between the 2 points. Based on this idea, we will compare the displacement and distance. The displacement is the final point minus initial point. Final point minus initial point. this final point minus initial point can be easily calculated for one dimension. So we take a line. This is the point A from which the particle is traveling, starting. Let this be 0. Let the particle reach B and let this be 5 meter. And the particle reaches C. Let this be 10 meter. The particle again reaches the point B. The particle starts from A, goes to this point, reach this point. Then the path length of the particle is this 5 meter plus this 5 meter, that is 15, plus this 5 meter. That is the total, it will be 20 meter. This is 5 meter. So 5 meter plus 5 meter plus 5 meter. That is, sorry, this is 15 meter. 5 meter plus 5 meter, 10 meter plus 5 meter. So the path length is 15 meter. But the displacement is this. This is the final position. This is the initial position. Initial position we take as 0. So final position minus initial position is 5 minus 0, which is 5 meter. And the direction is from A to B. If this particle starts from here, reaches 5 meter, comes back to the original point O, and then travels in this direction by 2 meter, then we can say that the total path length will be 5 meter plus 5 meter, 10 meter plus 2 meter. So in this case, the path length or the distance travelled is 12 meter. But the displacement is final point 2. This is final point is 2. This is the initial point from which we are starting. So this is the vector. This is minus 2 meter. Final point is 2. Final point is minus 2. Initial point is 0. So this is minus 2 minus 0. That is equal to minus 2 meter. This can be, displacement can be positive or negative. It can also be 0. Consider a particle starting from here. It is moving like this and coming back to this point itself. Then it has a path length like this. This is the path length. But the displacement is the initial point and the final point coincides. Therefore, the displacement is equal to 0. Displacement is equal to 0. So displacement can be positive, negative or 0 in one dimension. In 2 or more dimensions, we have to describe it using the mathematical theory of vector analysis we will see later. And the displacement will be final position minus initial position, that will be the magnitude. It is a vector directed from the initial position to the final position. So we will compare this. This is the, on this side I have the distance, which is the path length. This is path length. On this side I have displacement, which is the shortest distance. Shortest distance. The first difference is that this is a scalar, this is a vector. So distance is a scalar, displacement is a vector. Unit meter, this also have the same unit meter. This is always positive, can be positive, negative or zero. Here we can make a general statement. Magnitude of displacement and the distance traveled need not be same, but they are same if the motion is unidirectional. That is, if the particle does not change its direction, that is called a unidirectional motion. A particle is moving in one direction alone. It is not reversing. Or it is moving along this line. It is not reversing. If it is a curved motion, that is changing direction. If it is going in a particular direction and returning, it changes direction. Something which is moving along a straight line without changing the direction, that is called a unidirectional motion. For a unidirectional motion, always the magnitude of displacement and distance will be same. Magnitude of any vector will be a positive quantity. So, displacement is a vector, path length is a scalar, and the magnitude of displacement will always be positive. But that equality holds only for a unidirectional motion. Before going how this displacement and distance are related to average speed and average velocity, before that we will see few numerals which will help you to strengthen your problem solving skills and also to reinforce the idea of path length as well as displacement. So this is the first question, first example we are going to consider. That is a very simple example. An insect, this is the question, an insect crawls along the x-axis, for 4 meter and y-axis for 3 meter. Find A, distance, B, displacement of the particle. So we are given the x-axis distance and the y-axis distance. Therefore, we first draw a diagram. This is the origin. We assume that the insect starts crawling from the origins because no other ideas are given. If it is given that it starts from some other point, you have to take that as the starting point. Here, starting point is not given, therefore you can take it as the origin. You take the starting point of the starting position of the insect as the origin. then this distance is given to be 4 meter. This distance is given to be 3 meter. Therefore, the distance travelled will be 3 plus 4 equal to 7 meter. Displacement is this vector. It's directed by an angle theta to the x-axis. Whenever we are speaking about a vector, we have to take the magnitude as well as direction. If direction alone is asked, you need to take only direction. If magnitude alone is asked, you need to take only magnitude. But if you are asked to calculate a vector in general, you will have to calculate the distance, the magnitude as well as direction. So this is square root of 3 square plus 4 square which is equal to 5 meter. So the displacement is 5 meter. And this angle theta, we know that tan theta is equal to 3 divided by 4 and theta is equal to tan inverse 3 divided by 4. Now I shall introduce an idea. This is a 3-4-5 triangle. This is called a 3-4-5 triangle. This is 3, this is 4, this is 5. And any 3 numbers which satisfies the condition a square plus b square is equal to c square is called a Pythagorean triplet. Pythagorean triplet. And this is the smallest Pythagorean triplet. All the Pythagorean triplets will be higher than this. If you take a 3-4-5 triangle, this angle is known, which is 37 degree, and this angle is known, which is 53 degree. This angle is 90. So we can calculate the sine, cosine and tan of 37 degree as sine is 3 divided by 4, cosine is 4 divided by 5 and tan is 3 divided by 4. Similarly, you can calculate it for the complementary angle 53 degree. Sine will be 4 divided by 5, cosine will be 3 divided by 5 and tan will be 4 divided by 3. Therefore, this angle theta is equal to 37 degree. So we have a vector having magnitude 5 meter inclined at an angle 37 degree in the anti-clockwise direction with the x-axis. Next question, we take a circle. A particle moves along a circle. Particle moves along a circle like this, and you are asked to calculate particle moves along a circle. We are asked to calculate, this is the one diameter, this is another diameter, this is the center, this radius is r. This is the starting point. It starts from A, and you are asked to calculate the distance and displacement for the cases of a quarter rotation, that is the particle reaches here. That we will work out first. So, for 1/4 of a rotation, quarter rotation, distance will be this arc length. Distance will be this arc length, and that will be A, B, C, and distance. Distance is the arc length AB. That is clearly 2 pi r divided by 4, because the total is 2 pi r, 1/4 of that will be equal to pi r divided by 2 meter. The displacement is this distance. This distance is the displacement. And displacement is the vector AB. This is the vector AB, and that is equal to, this is R, this is R, therefore that is having a magnitude root of R square plus R square, that is equal to root 2R meter. That will be the displacement. And this angle theta, this is R, so this is an isosceles right angle triangle, so theta is equal to 45 degree. This angle is 90, this added together will give you 90, this side and this side are equal, therefore these two angles are equal, so it is 45 degree. Now, half of rotation. Half of rotation is the particle reaches the point here. And therefore, distance is equal to pi r, half of 2 pi r. This distance is pi r. And displacement is this AC. Displacement is the vector AC, which is clearly equal to 2r. And this angle is 180 degree, therefore it is along the x-axis. If I take this as the x-axis and this as the y-axis, it is along the x-axis. And if it, for complete rotation, it reaches here, full rotation. Distance clearly equal to 2 pi r, and displacement is equal to 0, because the particle reaches the starting point again. If it reaches the starting point again, the particle will have a displacement equal to 0. This is a pretty simple question, but sometimes the question will be slightly more involved. Instead of giving the trivial half rotation, quarter rotation, etc., sometimes the question will be like this. A particle, this is the center, this is the radius, and radius is taken to be r. The particle starts from a point A here and reaches another point B here, and this angle is given to be theta. You are asked to calculate the distance as well as displacement. How to calculate the distance? This distance AB, for 360 degree, it will be 2 pi r. So this is 2 pi r divided by 2 pi, that is in radian. This is for unit 1 radian. For 2 pi r, for 2 pi radian, it is 2 pi r. So 1 radian, it is 2 pi r divided by 2 pi, that is equal to, this is for unit radian. and therefore for theta radian it will be equal to r theta. That is a very important relation which we use to calculate the arc length. But remember that r theta formula can be applied if theta is taken in radian, not in degree. It should be taken in radian. Pi radian is 180 degree, 2 pi radian is 360 degree, 90 degree is pi by 2 radian, 45 degree is pi by 4 radian, 60 degree is pi by 3 radian, 30 degree is pi by 6 radian. So we have to express the angle in radian. Now we have to calculate the displacement. That is this. This length is calculated very easily by using geometry. That is, you draw a line like this. This is a perpendicular line. This angle and this angle are equal. This angle and this angle are equal. This is congruent. This side is common. Therefore, these two triangles are congruent. So this angle is theta divided by 2. And AC divided by R is equal to sin theta divided by 2. Or you have AC is equal to R sin theta divided by 2. AB is equal to 2AC. So this distance AB, which we have to calculate, will be twice the value of R sin theta by 2. So remember this. In this situation, that can be calculated by using a formula which it is easier to remember. 2R sin theta divided by 2. This is the length. And it will be a vector directed from A to B. This will be a vector directed from A to B. And since this is given symmetrically, this is along the y-axis. You can do the same procedure for angle taken anywhere. If theta is equal to given to be 120 degree, then your AB will be equal to 2R multiplied by sin 60, which is 2R multiplied by root 3 divided by 2, which is sin 60, which is equal to root 3R. So we can calculate the values of angle, any angle given. If this angle obviously is 90 degree, then that is equivalent to a 45 degree, and 45 degree will be equal to, this is 1 by root 2, and that will be root 2R, the result we have obtained earlier. For any value, this formula can be used. So remember this as an important formula. This distance AB is 2R sin theta divided by 2. This is true for any triangle. Now we take another interesting question, that is the question corresponding to the disk rolling. That is a rolling disk. You consider a disk like this, or a ring, and I take a point P here, which is in contact with the ground, and this is the center. This disk is moving like this, and it reaches here. Say this point P will now be here. This point will be here. It is again revolving. This point will be here, and it is again revolving. This point will be here, like this. It has completed half rotation. When it has completed half rotation, the point P has reached this point. This is the point P. Call it as P prime. And we are asked to find the distance and displacement. First of all, we will calculate the displacement. Displacement is this distance. This is the displacement. This distance, this has a radius r. This distance is 2r. This distance corresponds to half rotation of the disk. If the disk rotates by half, it will move by a distance equal to pi r. If it rotates fully, it will move a distance equal to 2 pi r. Therefore, half rotation corresponds to a distance equal to pi r. So, this distance P, displacement P prime will be equal to square root of pi square r square plus 4 r square. We can take r square outside the root sign, r root of pi square plus 4 meter. If you are given the value of r, you can substitute and calculate the displacement. And this angle is theta, and theta clearly will be tan theta clearly will be equal to 2r divided by pi r, which is equal to 2 divided by pi. This angle do not depend on the radius. It is 2 divided by pi, and theta will be equal to tan inverse 2 divided by pi. Tan inverse 2 divided by pi. Now we calculate the distance. That is slightly tricky. Usually in questions it has appeared to calculate the displacement, but distance also can appear. That gives you a very interesting curve like this. You imagine that this has undergone full rotation like this, and the P has reached here. P here, here, like this. And if you consider the trajectory will be a curve somewhat like this. This is half of that. This is the total curve. This curve is an extremely important curve both in physics and in mathematics. And this is considered to be the most beautiful curve in geometry, and therefore it is usually called Helen of geometry. Helen. Helen is the symbol of beauty. Helen of geometry. The name of that is a cycloid. It was first studied by Galileo himself, and later several other people have studied it in detail, and we have a very rich literature of the geometry of this particular figure. That is very important. And the distance, or we can call it as the circumference of this cycloid, that is equal to 8r. For a circle it is 2 pi r, that is 6.28 r. For this curve it is 8r. You remember that. You don't need to derive that now. In higher classes you will learn how to derive this expression for this distance. And area is 3 pi r square. That is also very interesting. the area of a circle is pi r square, and 3 times that is the area of a cycloid, which is 3 pi r square. 4 times it will be the area of a sphere, which is 4 pi r square. Pi r square for a circle, 3 pi r square for a cycloid, 4 pi r square for a sphere. These, it is better to remember this because this particular curve appears several times in physics. When you learn rigid body dynamics, etc., you will find this particular situation for a disc or ring rolling without slipping, etc. So it is very better to reinforce that idea now itself. So this is this distance. So the distance equal to, here displacement is this, and the distance equal to 4r. For a full rotation, it is very simple. The distance will be equal to 2 pi r, and the displacement will be this vector, which is 2 pi r, and the distance will be 8r. This will be 8r. So that is the situation of a cycloid. So this also is a very important question. That is, different aspects, and I have introduced this question to give you the idea of a very important geometrical object, which is called the cycloid. We will conclude with another very simple question. A particle, a man walks 50 meter due north, meter due east, and 20 meter due south. Calculate the magnitude and direction of his displacement. So we draw a figure. He is moving from here, 50 meter due north. He has moved in this direction. This is the north direction. This is 50 meter. Then he travelled 40 meter due east, and then 20 meter due south. So he reached here. We have to calculate the magnitude and direction of the displacement of that person. We know that this is the displacement. The particle has travelled like this and reached here. Obviously, the distance travelled will be 50 plus 40, 90 plus 20, 110 meter. And this distance, this is total 50, this is 20, so this is 30 meter, this is 40 meter, this is square root of 40 square plus 30 square, which also is a Pythagorean triplet, therefore we get it as 50 meter. This angle theta is tan theta equal to 30 divided by 40 equal to 3 divided by 4, and we have seen that 3 divided by 4 represents a 37 degree. So the displacement is a vector having magnitude equal to 50 meter and inclined at an angle 37 degree to the x-axis.